Welcome back to the deep dive. Okay, today we're jumping right in. We've got this collection of sources, and we're using it like an X-ray, looking into nature's, well, secret arsenal.
Yeah, some pretty wild stuff.
We're diving into extreme biology, these really astonishing survival tactics. Honestly, they make most movie monsters seem kind of tame.
They absolutely do.
So, our mission today, pretty straightforward. We want to get to the quickest path to understanding biological self-preservation, but focusing on the real aha moments,
Right.
I mean, if these creatures are inventing chemical weapons and physical explosion systems, we need to know how and why.
Exactly. And the sources really back this up. We have to kind of reset what we even think of as defense. It's way beyond just sharp teeth or running fast.
Yeah, forget camouflage for a second.
We're talking hidden tactics, super specialized, and often, frankly, lethally effective in ways you wouldn't expect. You're about to see that sometimes the most harmless-looking thing is carrying the most advanced weapon.
Okay, let's unpack that, starting with liquid projectiles. The horned lizard seems slow, right? Looks like an easy snack.
Totally. Seems vulnerable.
But the sources detail this absolutely shocking final defense. How does a lizard weaponize its own body?
It's incredible, really. It's about physiological control pushed to the extreme. So if the camouflage fails and the spiky armor doesn't work and puffing itself up isn't enough,
Then what?
it basically forces its own blood pressure way, way up, dangerously high.
And that pressure is the key.
That's the key. It ruptures tiny blood vessels around its eye sockets.
Oh, wait.
Yes. And it turns its eyeball into this kind of pressurized nozzle, shoots a stream of blood up to, 1.5 meters?
1.5 meters, that's got to shock any predator, just the surprise factor alone.
It is a huge shock factor. And the blood itself isn't just startling, it's nasty. The sources say it has this foul taste and smell.
So it's targeted.
Yeah, specifically repels things like foxes, coyotes, wild dogs. And what's amazing is, even though it looks incredibly dramatic, maybe even harmful, the lizard recovers almost instantly.
Wow.
It's high risk, high reward, using a common body fluid as a specific chemical weapon.
Okay, so weaponizing blood pressure and bad taste, that's one way. But still just liquid. What about generating actual force? Internal heat.
Oh, okay, yeah. Moving from bleeding defensively to actual internal explosions, you have to talk about the bombardier beetle.
The walking grenade.
Pretty much. This tiny insect is basically a walking chemical plant. The sophistication is just, well, it's amazing.
How does it manage that? An explosion without blowing itself up?
It's all about separate storage, clever design. It keeps two key chemicals, hydroquinone and hydrogen peroxide, in completely separate glands.
Yeah.
Only when it's really threatened, like right now, does it mix those two in this special thick-walled reaction chamber near its rear end.
In that mix. Boom.
Big time. It's a thermal reaction, hits 100 degrees Celsius, boiling hot, and makes this loud popping sound.
Boiling hot spray. And it can aim it.
Like a little water pistol, yeah. A scalding, irritating gas blast.
But how does it not cook itself?
And here's the really neat bit of engineering. Its body has an insulating layer. It's protected from its own 100-degree weapon.
That's crucial.
It is. The sources even have that incredible story, right? Where a frog swallows one.
Oh, yeah.
And the internal explosion is so painful, the frog immediately spits the beetle back out, alive.
So the defense works even after it's been eaten. Talk about redundancy.
Exactly. It's amazing.
Okay, from heat and explosions to, material science. Let's talk hagfish, the slime eel. What's its deal?
Right, the hagfish. Its specialty is basically suffocation and entanglement, pure goo.
Your defense?
When it feels threatened, it instantly pumps out this thick mucus from glands all along its body. But the really staggering part is the speed and the sheer scale of the expansion.
How much expansion are we talking?
Okay, get this. Once that mucus hits the seawater, it swells up to 10,000 times its original volume.
10,000 times.
10,000 times,
Yeah.
instantly.
So the water around the attacker just becomes this thick, fibrous,
Mess.
a suffocating cloud, yeah. It clogs their gills. The attacker has to basically flee just to breathe again.
And the hagfish itself, how does it not get trapped in its own slime?
It has a trick for that too. It literally ties its body into a knot.
A knot?
Yep, a knot. And then slides the knot down its body, scraping the slime off as it goes, slips right out.
That's clever.
But the bigger picture here, the so what, is that this slime, it's actually a super material.
Really? The slime?
Yeah. The sources point out the fibers in hagfish mucus are incredibly strong. Stronger than nylon, actually.
Stronger than nylon from a slime eel.
People are seriously studying it for things like bioplastics, new kinds of textiles, all from a defense mechanism that's basically just gross.
Nature's material science. Always a few steps ahead, isn't
Right?
it?
Always.
Right, let's pivot away from chemicals and slime into just sheer physical force, disproportionate force, mantis shrimp.
Ah, yes. Small package, big punch.
Big reputation, too. One of the most violent fighters, they say. And rightly so. It uses these specialized hammer-like arms, but the magic isn't the hammer itself, it's the speed. Just raw speed.
The sources said over 80 kilometers an hour. Underwater, that seems impossible.
It's incredibly fast, and that speed does something amazing with physics. It creates a cavitation bubble.
Cavitation, like on a propeller.
Exactly like that. The punch is so fast it literally boils the water, creating a vacuum bubble. But the real damage isn't the hammer hitting. No. It's the collapse of that bubble microseconds later. That collapse releases a huge amount of energy, superheated, intense shock wave.
And that's what breaks shells.
That's what breaks crab shells, clam shells, and the famous aquarium glass. It's weaponizing water with physics.
Just to buy time to escape, usually.
Mostly, yeah. Just needs a split second to get back to its burrow.
Yeah.
And the hammer itself has got this built-in shock-absorbing layer so it can keep punching without shattering its own limb.
Another layer of protection. Smart. Okay, sticking with physical extremes. Pufferfish. A double threat, right? Size and poison.
A classic example, yeah. Dual strategy. When it's scared, the inflation is almost instant.
Sucks in water.
Sucks in water or air, uses this super flexible sac, basically doubles in size, instantly too big for most predators to swallow. Plus, you often get spikes popping out.
A spiky balloon. Hard to eat.
Very, but that's just defense number one. The real backup is the poison. Lethal stuff.
Tetrodotoxin. The sources emphasize how potent that is. Much stronger than cyanide.
Exponentially stronger. It's a neurotoxin. Paralyzes the nervous system. Stops breathing.
And the fish itself is immune.
It has to be, yeah. Specialized biology to handle its own toxin. But what's really wild is how persistent the poison is.
What do you mean?
The sources note it stays active even after the pufferfish dies. Even if a predator eats it, the predator can still die from the poison later.
A posthumous defense.
That
That's
was-
dark. Eat me at your own peril. Literally.
Pretty much.
Okay, so sometimes it's not speed or poison. Sometimes it's just good old-fashioned armor. The pangolin.
Absolutely. Covered head to tail in these bony plates like shingles, osteoderms. It's just a fantastic natural armor.
And some of them take it a step further, right? The three-banded pangolin.
That one's optimized the armor. It has incredible flexibility in its joints. It can curl up into a perfect, solid ball.
Completely impenetrable.
So the sources say, even big cats, like leopards, apparently can't find a way in. Can't bite through, can't crush it. It's like a living armored sphere.
A rolling safe.
A rolling safe, exactly. But not all pangolins can do that perfect curl.
Oh.
Yeah, there's a sad contrast. Some species that can't roll up properly, they resort to just jumping straight up in the air, maybe a meter high.
Jumping, how does that help?
Pure startle factor. Confuses the predator for a second, buys time.
That sounds less effective than the ball. Kind of desperate.
It is, and there's a tragic downside. That same jumping instinct makes them incredibly vulnerable to getting hit by cars.
Oh.
Yeah, a survival trick that backfires completely in a modern environment really highlights why that impenetrable ball is such a superior strategy.
Definitely. Okay, let's shift gears. From armor and force to intelligence, illusion, performance art almost, the masters of deception, starting with the mimic octopus.
This one is just phenomenal. It's not just camouflage blending in, it's actively changing its identity, shape-shifting.
Goes way beyond just changing color.
Way beyond. It can physically imitate the shape, the texture, even the movement of more than 15 different marine animals.
15. So if a predator comes along.
If a shark swims by, it doesn't just hide. It might flatten itself and undulate like a venomous sea snake, or maybe spread its arms and change color to look like a toxic lionfish.
Becoming something the predator actively avoids.
You smart.
Incredibly smart. And the mechanism is stunning. It has total conscious control over millions of these tiny pigment cells, chromatophores, in its skin.
Millions. Allows instant changes in color, pattern, even skin texture. And its arms are so flexible, it can perfectly mimic the shape of, say, a spiny fish or a flatfish. It fools predators completely. The threat it projects isn't real, but the perception of threat is.
The level of control is just mind-boggling. Okay, from underwater shapeshifters to a caterpillar that pretends to be a snake. the snake caterpillar.
Yeah, this little larva uses pure bluff, pure theater. When something threatens it, usually a bird,
What does it do?
it inflates the front part of its body, puffs it right up into this broad, surprisingly convincing snake head.
Complete with fake eyes.
Fake staring eyes, scale-like patterns, the works. And then it adds movement. It wiggles its body a bit to complete the illusion.
And that's enough.
Usually, yeah. Enough to scare off a bird without any actual fight. Just brilliant, low-cost mimicry to avoid becoming lunch.
Clever. Similar idea, but maybe more dramatic, is the owl butterfly.
Right. A great double strategy there. When it's resting, wings folded. It looks exactly like a dead, dry leaf. Brilliant camouflage.
Blends right in. But if that fails,
If it gets startled, it snaps its wings open instantly.
the big reveal.
Exactly. And reveals these huge, startling eye spots on its hind wings. They look remarkably like the eyes of a big bird of prey, like an owl.
Ah, the owl butterfly. Makes sense.
That sudden, massive face staring back is enough to frighten smaller birds trying to eat it. Buys it just that fraction of a second needed to fly away.
Invisible 1 second, terrifying the next.
Yeah.
Pure theater.
Oh.
Okay, brings us to our last category, ultimate sacrifice and hidden power. And nothing says extreme like the exploding ant.
Yeah, this is intense. Found in Southeast Asia. These specific worker ants practice what's called autothysis, basically defensive suicide.
Suicide for defense.
It's incredibly rare. Altruism in the animal kingdom. When the colony is under attack by something stronger, these workers, they contract their abdominal muscles so hard that their own bodies rupture. They explode.
Seriously, what does that achieve?
The explosion releases this sticky, toxic, bright yellow goo. It coats and immobilizes the attackers.
So the ant dies instantly.
Instantly. But the sources call it a heroic act because it saves the colony. It neutralizes the immediate threat, allowing others to survive. Group survival over the individual.
Wow, that's a heavy price for defense. Okay, from that to something a bit more, well, electric. The electric eel.
Right, though first clarification, technically not an eel. It's a type of knifefish, actually more related to catfish.
Good to know. So how does the shock work?
It has thousands of specialized cells called electrocytes. Think of them like tiny biological batteries all lined up.
And when threatened?
They all discharge at the exact same moment. Creates a really powerful high-voltage shock, enough to stun or paralyze prey, or definitely repel a predator.
ZB.
Pretty much. But the electricity isn't just a weapon, it's also sensory.
How so?
It generates a weak electrical field around itself all the time. It can sense disruptions in that field, which is how it sees or navigates in the really murky waters of the Amazon and Orinoco where it lives. Vision wouldn't work well there.
So it's navigation and defense in one package. Clever. Okay, our final and maybe weirdest defender, the sea cucumber. Looks harmless, right? Just sits on the ocean floor.
Totally unassuming. Important job, though. Kind of like an ocean vacuum cleaner. But yeah, its defense is extreme. It's called evisceration.
Evisceration.
Sounds bad. It was. When it's seriously threatened, it forcibly ejects its own internal organs out of its rear end.
It throws up its guts, out its butt.
Basically, yes. These sticky, often toxic, thread-like organs called covarian tubules, they shoot out and entangle or poison the attacker.
Giving the cucumber time to escape.
Exactly. The predator is left dealing with a sticky, toxic mess of guts, and the sea cucumber crawls away.
But it just ejected its organs. How does it survive?
And here's the truly mind-blowing part. It just grows them back. Regenerates the whole set of lost organs within a few weeks.
Regenerates its internal organs? That's incredible resilience. Temporary mutilation for guaranteed survival.
It's an amazing trade-off.
So if we try and wrap this up, looking back at all these sources, the level of ingenuity is just, well, it's astonishing, isn't it?
It really is. Chemical explosions, weaponized physics like cavitation, incredible mimicry, even self-destruction. Evolution's toolkit for survival is just endlessly varied and creative.
And it totally flips the script on power, right? We saw it over and over. The smallest, maybe slowest, seemingly weakest creatures, they often have the most disproportionately powerful or just brilliantly clever defenses, like that hagfish slime being stronger than nylon.
Exactly. That's the big takeaway. Nature's R&D department is just unbeatable.
Which leads to maybe a final thought for you listening out there.
Yeah, think about this. If a creature like the hagfish, pretty simple really, can create a natural fiber stronger than something we engineer like nylon, just as a defense, what other amazing materials or maybe even biological processes are just sitting there, overlooked, hidden in the survival tricks of seemingly ordinary animals?
What breakthroughs are waiting just by watching closely. Keep your eyes open out there. You might be looking at the next big thing.